Good afternoon, everybody. I'm very happy to see you here, both physically as well as online, participating in this discussion today. Our team has been very excited about this particular project. And one of the main reasons why we are very excited about this project is the focus at Institute for Future Health and some of the activities that we have been working with ISO in this particular aspect are very directly related to some problems that we think need to be seriously considered in healthcare area, and we need to solve some of those problems. So let's start with that aspect first. We believe that the current healthcare challenge is that we treat healthcare in a repair model. What do we mean by repair model? We think about healthcare only when we are sick, when we need to get something fixed. And this is no different than getting any other thing fixed. Whether it's your computer, whether it's your car, or whether it's your body. In all the cases, we start thinking about measuring different parameters, trying to understand what is going wrong with you, and then trying to fix that particular problem. We all know that our health is a lot more complex than a car or even a computer. So when we try to fix this health also in that particular model, the result is obvious all across the world. What we see is health costs going up, particularly in the United States, and the quality of healthcare becoming of concern to everybody. And that's because healthcare currently works in repair model where we don't get cost estimates and we do not get any kind of guarantees. Moreover, we also don't understand what's going on with us. So how can we solve some of these problems? This is not a new problem. Lots of people have been thinking about this from many different disciplines, including informatics, but mostly in health sciences also. And one of the things that we will have recognized very clearly is that we should consider health in three very clear stages. Number one is how can we provide people reliable, trustworthy health information that's not only trustworthy and reliable, but also accessible and understandable to people. Currently, healthcare is so complex that most people do not understand when they are provided the information. So how can we provide information in a way that everybody, whether that's illiterate person from a remote area or even very well educated people, many of those who are attending this particular meeting here, who otherwise are very well trained, but as soon as we go into healthcare, because of the complexity, because of the jargon, we don't understand what's going on. The second thing is the current healthcare is considered in episodic mode. Can we make it perpetual? Because our health does not start and end in hospital. It's always going 24/7 with us. How can we consider health taking place all the time and we are getting the guidance related to that? Moreover, it is now very well recognized that most of the serious problems are the chronic issues. And those chronic issues are more influenced by our lifestyle and environment, plus some factor from genetics, than the medication. How can we bring all these aspects into this? And with respect to that, at IFH as well as in ISO, we have been talking about personal health navigator. So the personal health navigation becomes the second important component. And the third is most important component is related to the current healthcare, where how do we diagnose a particular issue? How do we prescribe medications for that? How do we make sure that people are following that particular prescription? And it is believed that more than half of the prescriptions are not followed because in most cases people don't even understand what those prescriptions mean. And once that happens, it becomes very difficult. Can we address these problems? We at IFS believe that though other aspects, social aspects, educational aspects are extremely important, but technology can play significant role in helping us implement those aspects very easily. So these three aspects are: number one, how do we provide accessible, trusted health information? That means how can we go beyond simple text-based information access that has been the traditional thing to speech-based or experiential information sources that can use multimodal experiential interfaces that are slowly becoming common. How can we start utilizing these things so that anybody in their own language, in their own local uh, context can get the information that they require? That is the first aspect that becomes very important. The second aspect is how do we allow perpetually to deal with some of these information sources so that as soon as I want to make any particular decision or based on biomarkers, I should be making different decisions, I could be informed. More like your navigation system, that once you have said that this is where I want to go, the system will not come in your way until you have to make a decision. When you have to make a decision, the system will come and help you make the decision. And that's what we want to start doing there. We will not get into the technical details of that, but we have been implementing this, and many of you in ISO are very interested in developing the architecture related to this so that people can develop different applications around this. And our friend Todd Cooper has been very excited and has been very supporting this particular thing, so much so that SL7 has adopted this approach also. We are working very closely on that. So that's one aspect. Finally, digital health has been very popular. We now have the AI-based diagnostic systems that are being used at many places. And people have been talking that in many cases, AI diagnosis works better than even experienced experts. Yeah. So in that area, things have been progressing quite well. But one concern has always been, how do we make healthcare to be more empathetic, more pupil-centered or patient-centered? And in this aspect, recently a group of us got together and we recently published a paper also on how do we develop foundation metrics for accomplishing this particular task. You may hear a little bit more about this later on, but with all these three aspects, one thing that becomes very clear is that AI can be applied in health for empowerment of people. Any problem that's serious enough for everybody in society cannot be solved by imposing particular rules. Empowerment is essential. Empowerment will allow people to take responsibility, feel responsible for it, and also other stakeholders to consider each person at the center of health. Unlike the current models where healthcare providers or payers or employers are considered central. In this way, people will become central. When we start thinking about this, there are three very important components that AI is contributing. The first that is normally talked about are the LLMs based systems. Everybody is talking about ChatGPT or Gemini or take any variations of this because we can collect a lot of knowledge that is available from different sources, and we can make it very easily available in conversational mode. So that has been extremely powerful mechanism, has been very popular. People have also started talking about foundational models. Multimodal spatio-temporal information plays extremely important role. And here, the goal is not just to collect standard knowledge, but also to put it in the form of a model, which could be used for predictive and preventive approaches. You cannot have a personalized medicine. You cannot have a preventive medicine until you have built very powerful models. And these models should not be at population level. We have to bring down these models at a personal level. So how can we start building these foundational models and use these models then for not only providing the trusted information, but also the navigation. And when we are doing disease management, use again these models in the context of an individual. These models can take us much farther than just personal information. They can take us to population-based things, but that's not the topic that we want to discuss today. What we want to discuss today and what you will hear and you will start implementing are related to health agents that try to combine the first two things. That is, how do we use LLMs for general knowledge? How do we start bringing in elements of foundational models? And based on those things, we start building what we started calling conversational health agents. So with that, Iman, please take over and tell people how you are going to make it happen today. Thank you very much.
Thank you so much. We have multiple lectures today, so we want to continue with like a talk on agents by Professor Amir Rahmani. So please.
Sure. I'll just give a quick kind of. I'll just try to be the segue here. Thank you. With the actual, I'm going to use this slide because today is all about openCHA. So I wanted to prepare the transition from a very nice visionary talk by Professor Jain to the actual, reason that we are also today to see what is a conversational health agent, work with this open instance of it that has been built in the Institute for Future Health, and also get to use it. So there's this cool hands-on session at the end. But as a segue, I just wanted to kind of raise awareness and discuss about, especially if, not all of the participants today are computer scientists, tech savvy people. We also have, let's say, health scientists, staff from, or researchers from nursing, public health, medicine, and so on. So I first want to differentiate between this notion of, as Professor Jain mentioned, this notion of LLM, or these large language models that are out there. Almost all of us have used them for, let's say, certain as a source to query our questions, to get to know new things, even sometimes for coding and so on and so forth. But there is huge hype around, and the downside of this hype, in my opinion, is that people try to use this hammer for every nail and forget about all the rich set of tools and skill sets that have been accumulated before that. So the idea is that how we can use these LLMs, how we can leverage their benefits but actually bring also the rich body of, let's say, literature on other aspects of AI, especially the agent models, to have the best of both worlds, right? So let me use this example. You may go to ChatGPT. Let me use GPT 3.5 as an example because that is an static kind of model, hasn't been updated since last year. But GPT-4 is a little bit different. So let me use GPT 3.5 as an example. So you may ask a question in the health context, like, how can I improve my sleep quality, right? And what you're going to get is a population level generic kind of information that has been used to train that GPT 3.5 model. We don't know if it's validated. It's definitely not personalized because it doesn't know anything about me as a person. Of course, I can give you a little bit of information through prompt engineering, but that's very limited. And also, I cannot use it to, for example, perform certain in-depth analytics. So what I get is a very shallow but broad model called LLM. But we should not also forget that there are also a rich pool of deep and specialized models that are kind of narrow. So there is, as I said, there is contrast between being shallow but broad and being deep but narrow. And the idea of these agents is actually have the best of both worlds. Why? Because when you want to ask this question, A, you want the agent to know something about you. So you want the agent to be able to personalize the information, so be able to retrieve your information. For example, your EHR data, your wearable data, your any modality that you're able to provide to it. So that's A, bringing data. B, you want also to be able to bring knowledge. And we have all these validated, for example, knowledge graphs in healthcare. For example, like NIH has this rich, for example, knowledge graph. Or you may have your own, let's say, knowledge graph on food or anything, and it's validated and can guide the recommendations to be grounded in actually evidence. And C, so we have so far data, we had knowledge, and C, we have models. Let's say you have already, with the help of your team, have built a very narrow but validated, well-tested deep learning model for a certain diagnosis, or maybe a causal learning model to assess the effect of nutrition on sleep. Why not plugging that also to your LLM so that you also get to outsource those specialized questions to those deep models rather than using the shallow information of the LLM. But still, the shallow knowledge of the LLM is very useful, and that's how an agent platform is capable of combining and amalgamating these kind of different sources. That's where we need an agent, something can decide, can plan when to use its own internal knowledge, when to call your data, when to call your use and import your model. And you don't want to hard code it. You don't want to just write a bunch of if and else and loops and so on, right? So you want that intelligent intrinsic planning capability of your agent to also take care of that. So the agent should be smart enough to understand when it should go and retrieve your data. You don't want to just code it there first, right? Because that will limit its kind of capabilities. Of course, you can also do that if it's already, for example, mission critical or something you want to really put constraints on top of that, but you also want to leverage the internal intelligence. That's what this lecture is all about. Today is all about openCHA, how to make this happen. We have a first prototype of a system that is capable of doing at least some of these basic capabilities, and Iman and the rest of the team are going to walk us through that. Thank you.
Sure. Thank you. Thank you so much. So thank you for the thank you for the introduction on openCHA, and thank you, Dr. Jain and Dr. Rahmani, to focus on the talk about the mission that we have, or the vision of our research here, and then why we came up with this framework. my talk will focus on three parts. First, the state of the art. So what's going on in the literature. Then I'm going to talk about like how we can make this happen. So yes, so there's a need of such kind of agents, how we can build them. And then we're gonna go through some demos, so like a video and some examples. I want to start by focusing on like agents, on chatbots or like conversational health agents. We will see these chatbots more in the future, maybe like in 10 years or 20 years. So we will see them like as an assistant to like maybe health professionals, or they can help patients in different aspects. For example, we may see such kind of chatbots for symptom checking or for diagnosis. We might see them for patient monitoring. Now, thanks to the technology and these wearable devices, these smart devices that we have, we can collect data. So these chatbots can use this data to provide guidance. They can help us to improve our lifestyle or diet or physical activities and so on. So these chatbots can provide awareness, self-awareness for us. So they could be like part of like the healthcare services that we receive in the future. But I have one question from the audience. Any of you, if you have a health question, you have a headache or like a stomachache or like anything, have you ever asked this question from ChatGPT? Anyone?
Yeah, I've asked.
You ask, and then
For headache, but
so what about the people's online? Have you asked any question, like for example, if you have a health problem from ChatGPT? Yes, I see 2 yes. Okay, but 3 yes online. But most of us don't ask. And I don't know, like if you ask a question, do you trust the response? But why? Yes, one
If you
question.
expand your question
Mhm.
to ChatGPT or Google, I think more yeses will come.
To Google. Okay, so do you ask a question from
search.
Google?
I think
So do you do Google search? Like for example, if you have a headache, you ask it, okay, so I have this is my symptoms, and then you get that. Do you trust like that?
I mean, that's the second part of the question. But first, yes, we go
Okay,
to
you
Google
ask.
and ask questions. Whether we trust or not is the second thing. But we definitely look for that information.
yeah.
Thank you. So I'm gonna focus on this trust part. So that's why I asked that question.
That's why I broke it up.
So we are like most of us are not using chatbots for like for example ChatGPT for asking healthcare questions, health related questions, and because of the challenges that we have. The first challenge that we have is trustworthiness. How we trust the response. Okay, so I have a headache and this is my symptoms, and the ChatGPT says that okay, so this is because of I don't know some disease. So can you take some medicine based on this recommendation? Of course not, because how we can trust that response. And another problem that is kind of the current existing chatbots have is lack of personalization. So when you ask a question, there is no context. So they don't know about your background, about your genome, about your lifestyle, about your diet, and so on. So the answer that they provide are kind of a general answer that could be used for anyone. And the third problem is lack of data analysis. So language models, like for example GPT, they are generative models. So they generate text. They are bad in data analysis. They cannot do computation. And lack of multimodal data analysis is another problem that this chatbot has, because when we collect data, when we collect objective data through a smart devices, through like health devices, these chatbots, the current one, they cannot analyze the data. They cannot analyze your MRI image. They cannot analyze your electrocardiogram signal and so on. Another problem is access to up-to-date information. Yes, GPT-4 is trying to address this problem by adding internet search. So when you ask a question from GPT-4, it just like it does a Bing search and then just like search and then give you the response. But this is like Googling that you mentioned. So can you trust like that reference or not? Probably not, because you don't know, it could be like misinformation or like it could be like any website. And another problem is explainability. So when you ask a question, you have no idea how this response generated, because like these transformers are like black box. So you get a very good response, but okay, how did you came up with this response? So this is another problem, and there are like many other problems, including like safety, privacy, and so on. As Dr. Jain mentioned, so we discussed like these problems in details in one of our publications that recently published by Nature, NPJ Digital Medicine. So if you're interested on this like problems and this kind of evaluation, so please go through this publication. So there are like these problems that now we have with chatbots. And okay, what's going on in the literature? So there are like different papers focusing on large language models in healthcare. So people are trying to use these LLMs in healthcare. For example, some people just use prompt engineering. So they just use ChatGPT and they try to ask a question through prompt engineering and do some experiments. Another like other studies focused on fine-tuning LLMs, or like one study like used a huge like a data set to pre-train a large language model using the data that it has for specifically for healthcare. Examples are Chat Doctor and BioGPT. Other studies focused on RAG-based LLMs. So in these studies, they were trying to integrate some medical information to large language models. And the last group here is the one focusing on multimodal health LLMs. So there are studies that are focusing on to integrate multimodal data into LLMs. But all of these groups cannot address the problems, like the challenges that I mentioned. For example, okay, so you might use prompt engineering to ask your question in a way that the chatbot understands, but how you want to address this kind of trustworthiness problem or like explainability problem. RAG-based LLMs can provide like information, maybe from reliable sources, but they cannot address this data analysis problem, lack of data analysis of LLMs. So the existing words are not enough. So this gives us the motivation to propose openCHA. openCHA, Open Conversational Health Agents. So we propose openCHA to integrate knowledge base, data sets. It could be structured or like unstructured data sets, and AI and analytical tools with LLMs. So you have a chatbot that can interact with these external sources to extract the information that you need and to generate the response. So this is like the main objective of openCHA. Here we see many components. I will go through them one by one, so don't panic. So there's one question, so please.
Now to make a comment, actually.
Sure, please.
Which even if you do all this, you still have your problem number one.
Trustworthiness.
Yeah. And
Sure.
the reason has nothing to do with this. The reason is because in your previous slide, you said health chatbots. The issue is the over misuse of chatbots per se. In today, when I go to any website, something pops up, and the first thing I do is I close it because it's an editor. It is similar to me receiving a phone call. 10 years ago, if I got a phone call, I would pick it up if an unknown number. Now I won't even pick up any unknown number because it's been misused.
Mhm.
So that's where the trustworthiness coming into play. May not have to do anything with health chatbot, but the surrounding aspect of it. So you may want to consider that.
Very good comment, and I have also some answer for that. So,
So I
thank
just
you.
wanted to comment on that.
That's great. So I can like highlight that like in the rest of my talk. That's a very great comment. So trustworthiness is like definitely is like the need here. So we have mainly three components here. The first is interface. The second one is this orchestrator. And the third component is external sources. Interface is like this, the GUI, so the user can interact with the chatbot. It can ask questions and receive the response. And within this interface, we also include like metadata. So you might have a question that needs some additional like data. For example, you ask that how is my like if I have arrhythmia or not. And when you want to ask this question, you need to also provide your ECG data to analyze that. So this interface receives the data, the files, and also the question, and provide a response to the user. So this is the role of the interface. And then we have this orchestrator is like the decision-making core of our framework, where we have mainly two LLMs. I will talk about them more in details in the next slide. But so the idea is that when you ask a question, it translates the question into some task to interact with external sources. And then when it gets the required information, it generates a response based on the information that it gets. So this all happens in the orchestrator, the second part. And then we have external sources that provide this information. And for this trustworthiness problem, this framework, so in a kind of a ChatGPT case, so the knowledge comes from this internal model of ChatGPT. So the reliability of the response or like trustworthiness depends on the ChatGPT. But here we kind of outsource this. So the reliability of the response is coming from these external sources. So if you trust these external sources, you could trust also the response. So this is like the main idea here. So I can give you some examples on this. So let's focus on these three components one by one. So this, as I said, like this interface is kind of the layer between the user and the chatbot. You can send a question and get a response, and then beside your question, you can also upload some metadata, including this could be like image, this could be in time series data, it could be a signal or anything. So the orchestrator part, we have two LLMs here. The first LLM here is for the planning part. So when you ask a question, for example, I ask a question that, okay, what is hypertension? And the first LLM acts as a planner. Okay, so this is the question. What external sources do I have? For example, one external source could be like a knowledge base. So you have a knowledge, like a digital library, description of like the details of hypertension, details of like different diseases, and these are like reliable sources. So this planner gives us some kind of a pseudocode or like list of tasks to interact with these external sources to provide the required response regarding that question. So the first part is to translate the question to some tasks. So this is the first part that's done with this task planner. And then through this task executor, so the tasks that are already defined by this task planner will be executed, and by interacting with the external sources. I will show you some demos to see that how this works, and then we will go through this also like in the next session in more details. And then when you have the required information, like for example, I asked that also, what is hypertension? The planner says, okay, so you need to get this information from this specific article. This task executor send a request for that digital library, get the information from that article, and then so the system now has this information about hypertension. Then the second LLM, that is like result generator, use this information to generate the response. We try to differentiate these two LLMs because the first one is just focused on the planning part, the decision-making part, and the second LLM focused on the conversation. So you have all the information, now you want to make it like in a human way, in a kind of a empathetic way, in a kind of like considering, for example, health literacy and so on. And then here we have one data pipe to store, it's kind of a temporary data set. So when you have, for example, a metadata, or if the LLM needs some to get some data from the patient, like for example from a server, so it's stored like here to do the analysis and so on. We'll give some examples also on this later. Any question for this orchestrator?
So, in other words, you're kind of using the planning capabilities of the LLMs in this scenario, not really kind of that language generation part, whereas actually you have another LLM for that, right? For the interaction.
Exactly.
This is like an engine for you to plan, to decide more the agent part, like what to do and from where to get it.
Exactly.
A couple of comments. One is the LLM itself can be multiple LLMs and
exactly.
maybe federated.
Yes, it could be.
So it may not be just your LLM, but you may itself.
Yes, so we make it kind of modular, so you can use any LLM.
That's one. Second one, which I'm sort of grappling with, is we are looking for answers and for certain questions. And why should we restrict it to an LLM only? There may be other sources which may be generating, may have the answer. Are we sort of?
Could you give one example?
Non-LLM, a human expert.
So human expert answer the question. So the idea is to like make it. What is that?
Also, besides.
Of course.
What I'm saying is, your diagram, what I'm saying is you should not convey that you are only restricted to an LLM to get.
I think there are external sources top there.
Knowledge base can also be a doctor that you can ask a doctor, the doctor can return the answer, and then the LLM will use it. So those external sources can be any trusted sources, which includes humans.
So yeah, the idea is that like this could be, for example, an assistant to a doctor. And this kind of knowledge base could be like the information that's provided by medical doctors. So
they're just showing the orchestrator here. And at the larger diagram, there are external sources, and exactly what you're mentioning. That's the reason why we need agents, because as you mentioned, not everything is available through LLMs, and you want external. Let's say maybe you already have a kind of a set of Q&As that have been tested, and you just want to retrieve from there, like a database. Or that's exactly why this planner can decide whether for these type of questions, I need to go and use those external data. So that's how you can implement this platform. They're just zooming into the orchestrator part. When they will zoom out to see the external API. Basically.
And also it's like an SLA, service level agreement.
Yeah.
Depending on which level, okay, initially you get it from the LLM. Now you want the higher level, maybe get an external expert or.
Yes. So the idea here is that like these LLMs, they do not generate the response. They interact with other existing knowledge tools and the data set that we have to get the response. So in this case, we have explainability. So if you have a response, you know exactly So how did you get this response? You got it, for example, from this tool that you already connected to this LLM. And then if the answer is wrong, it's not because the LLM failed. It's because like your model or your knowledge base is not accurate. So the reliability of the answer is like depend on these external sources. So here we define this in our paper like 4 types of external sources. The first one is health data sources. This could include like any kind of health data that we can get from patient. It could be like variable data. It could be EHR, like textual data. It could be tabular data. It could be like image data, MRI, and so on. So these are just like the data set that if you ask a question that the answer should be obtained from these data sets, this planner interact with this, for example, this server and get the required data. The second component is this knowledge base. This could be search engine. This could be retrieval models, a knowledge extractor, and so on. So these are like these, it could be like a knowledge graph. These are like the knowledge bases that defined and designed by domain experts. And then we have these AI analytical models. So when we already have tools or like models that can take care of this data analysis, and then we already tested them, we already evaluated them using like data that we have in studies. So why we don't use them? So these external sources help us enable us to so LLM can interact with these analytical tools. For example, you have one MRI image, and you have also like there are some, for example, tumors in the image. So you want to ask a question about this tumor. So LLM cannot answer that, and it's wrong if you ask from the LLM directly. So here in this case, so when you ask a question, this planner interact with this data source to get the MRI for that patient, and then it interact with this AI model. So you already developed one AI model trained for MRI, like tumor detection and so on. So this like planner part, the planning part, send this MRI image to that model and ask for this like report or like any kind of this. And then when it gets the reports, it use it to generate the response. So this is like the main idea. And then we also included like one component as translator, because we wanted to keep all of this planning part like in English. So if you have a question, for example, in another language, in Spanish or like a language, the first item in the planning is to translate this to English, and then like do whatever needed to interact with these external sources. And the last step is to translate it back to the original language. So these are like the main components of the external sources. And today in the hands-on exercise that we have, we're gonna have like two of these components, like this variable data. So we give you a variable data and ask you to connect it to the openCHA. And also we have you can also list like this search engine to get information from reliable websites. We have a couple of demos, but I want to also check time. So we have about 10 minutes. So I can play this one, but I need to also share my audio. Just share sounds. Okay. So this is the demo that we published this in one paper in one of our articles published in Elsevier Smart Pills, and so this is about the chat diet. So the idea is that we have a chatbot to use this openCHA framework, and then it provide food-related recommendation. And as external sources, here we have variable data, we have a causal model, personal causal model that we already extracted from the variable data, and then we have like some general guidelines. For the data, we are using data collected from one person for 3 years. So we have like this sleep data of the person, physical activity, and he also logged like their daily food consumption, like breakfast, lunch, and dinner. So we have all this information, and then we connect this LLM to this information, and then we are asking questions related to this food recommendation. So we see the demo of this, and that's how this works. Okay, so the sound doesn't work. Maybe.
Is that a Zoom you're using?
Yeah, I think
You need to go back completely and then select the.
Yeah, I did. Yeah, I muted my laptop, so that's the problem.
In this video, we demonstrate an example of personalized food recommendations on openCHA. We first select the tasks that openCHA can perform to generate the response. We select the task to interact with users' food data and health outcomes collected from external wearable devices, and one task utilizing causal inference algorithms to estimate nutrition effects. Then we take 2 tasks retrieving food nutrition content relevant to the user's query and requesting additional information from the user. Let's start by asking the agent to show my personal nutrition. In this video, we estimate nutrition effect. Then we take 2 tasks retrieving food nutrition content relevant to the user's query and requesting additional information from the user. Let's start by asking the agent to show my personal nutrition effects on a specific health outcome, such as deep sleep. To do this, openCHA will collect data from a food log and deep sleep information tracked by a wearable device, subsequently estimating the causal effects of nutrition on deep sleep. The response will reveal the nutrition effects on deep sleep, with values indicating the estimated average treatment effects of the nutrients per unit. We can also ask for food recommendations by querying the foods to improve certain health outcomes. For example, we say like, could you recommend me a food to improve my deep sleep duration? This will trigger the agent to execute the retrieve food task to obtain the relevant foods and their nutrition contents and personal nutrition effects. The response demonstrates the food suggestions to improve the deep sleep and the explanation based on the estimated personal nutrition effects. The recommendations are explainable. By querying with "Please explain your recommendations," openCHA will display the rationale behind the food choices, focusing on their nutritional impact. But what if you're missing an ingredient or food? No worries. openCHA's interactivity comes into play. Remember that this isn't just a static food list. It's a conversation with your dietary needs. Ask a follow-up question like, I don't have the recommended foods. What are my alternatives? And openCHA adapts, offering alternative suggestions. By calling the tasks, openCHA not only delivers nutrition-oriented food recommendations but also enhances the user experience with personalization, explainability, and interactivity. This ensures a more user-friendly approach, tailored to individual needs and preferences, enabling users to make informed dietary choices and adapt suggestions to fit their unique health goals and lifestyle.
To add something here.
Sure, go ahead.
Yeah. Just to clarify, because it may sound, because in the demo at the beginning, it shows that you select certain kind of tasks. Selecting those tasks is not, it's just for the sake of presentation, showing that
like programming that at the beginning, you define certain libraries, right? You just say that these are the things that I may use or may not use. So not enforcing the model to use it, you're just making it available to the model. So, and then when the model, the beauty of this thing is that the planner understands when, because you write a human description for that task, say that this task, description in human language, for example, you said this task is designed to do this, as input it receives blah, in a very natural language. And then the LLM, because it has a description, intelligently can understand when to call it. So you're not hard coding that piece. The planner, the LLM planner is supposed to do that. So that lower kind of, that bottom part is just to show you that you can define tasks and import it here and let the planner choose it on demand. So you're not kind of, as a user, like a final user, you're not going to see that bar. That's only for a developer, perhaps. Yeah. Or even the user, you may also, the user want to give the option to kind of do that.
That was a really good point. Like this interface that we design, like in the open source position, is like more for developers. So you develop some task and you want to connect it to this openCHA and you want to test it. You can also select all of them and then this planner selected like automatically. So it's just like hard coding. And so regarding to your comment about the trustworthiness, so when we get a response about like the food recommendation, this is all coming from these external sources, not from LLM. So if you trust these external sources, you may also trust this response. So that's the objective here, to make it kind of transparent and then rely on these external sources to get the response.
And the users are not limited just to end users, like, for example, a person. And a user can be a clinician. For example, this can be an assistant for the clinician asking, for example, the clinician can ask, can you summarize the data of the EHR of this person the last 1 year? I'm going to prescribe this medication. Do you see any, for example, conflicts with everything else that that has been going on, the history of this person? So it can really go and kind of, it's like a also assistant to the clinician. So it's not always a patient front or patient-facing chatbot. It can be for different type of stakeholders.
Thank you. So we have 4 demos, but maybe I skip some of them to save some time for questions. So this is like another demo. So in this case, just like a simple question that about like the question is like about diabetes, and so what are the key risk factors linked to diabetes, and what measures can be implemented to prevent it? Provide references if available. So to answer these questions, this planning part, this orchestrator interacted with interest search, and then we defined some reliable websites, like for example, My Clinic, CDC, Puppet articles, and just like find these answers from like 2 references. One from CDC regarding this diabetes risk factors, and for the prevention measures, it got this information from My Clinic. So and I jump to the last like demos that I want to show here. So in this case, we ask a question that, for example, give me the patient 5 stress level during August 2020. And then to test to do this like test, we use a data set collected for 1 year using smartwatches, smartphone, and a smartphone, a smart rings, and a smartwatches. And then this is a portion of that data. So we provide the data of multiple patients, and then through heart rate variability, so this we can extract this stress. So we provide this PPG data from the smartwatch. We connect it to this LLM, and also we connect some like models to analyze PPG data. And then the model could interact with this data, with this PPG model, to extract a stress level. And then when it gets the information from the stress level from the PPG data, it generates a response. So this task, this example, this demo includes like data analysis and how interaction with the data analysis model. So for the future direction, I want to talk about this, that we are looking for collaborations from diverse communities. So this is so we developed this code based on this openCHA framework, but it needs a contribution from different domain experts who already have tools, who already have data set and knowledge base, so they could connect this to their own data set to the LLM, and then so the chatbot can interact with these external sources and provide responses. We are focusing on the safety of the responses and in collaboration with different teams, and we are currently working on this the planner part, how we can improve it using fine-tuning and prompting, and in collaboration with multiple researchers, we are also focusing on connecting knowledge graph to this LLMs. For example, how we can connect the knowledge graph to a planner part, so to improving this kind of decision making and planning, and also as external sources. And we saw also one example of about the food recommendation. So we are also focusing on food related applications, so food navigation and food recommendations. Thank you so much. Time. Any questions or comments?
Yeah, okay. I have one here.
Sure.
So it's very interesting that you also spoke about what different state-of-the-art LLMs are available, and how conversational agents is somehow a combination of all these, right? And definitely looking from the application perspective, I saw there are some companies are just Whoop AI released its own collaboration with AI Coach by using GPT-4, OpenAI's GPT-4 model for giving personalized suggestions on how to exercise and how to be more mindful and everything. The challenge there was, of course, Whoop didn't release its model, but then one aspect that I envision CHA being used is for personalized wellness coaching, and I've seen also Apple and Fitbit having plans for implementing something like this. And one direct thing is also related to Aura. Aura already has all this data, right? And also Aura Ring has the API key available for readiness, for activity, for sleep. So I think I'm assuming that is one of the exercises that we're going to be doing later today, but also more from an application perspective. I feel it's going to be valuable to implement this, but what challenges do you envision in putting this into an actual product or giving it as a service for a larger scale?
So first of all, this open source openCHA that we have is like a framework, so it's not a product.
Yeah.
So so there are different deployment challenges. Like for example, privacy could be a problem. So it depends on the application. So if you have a sensitive information, so you need to generate. When I was talking about this orchestrator here, so we are testing this with OpenAI ChatGPT 3.5 Turbo. So in the case of if the privacy is a problem, so you cannot use that, or you could use other LLMs. So we make it kind of modular, so you can use your LLM. So implementing such a system for a product, so there are many challenges, like privacy, or it could be the safety, especially in healthcare. You ask a question that, okay, can I take this medicine? Of course, it should not provide a response to that. So
got it.
Use that antibiotic or something. So that's the wrong answer. So safety, there are many challenges that need to be addressed.
Thank you.
Any other question from audience?
Not a question, but a comment.
There are some questions in chat.
The chat, yeah.
Yes. what part of this diagram is actually implemented as the openCHA framework? Most of them, I would say. Some of them is like under construction, like for example, this metadata. What was it?
You can show the diagram explain. Because that's a good
Yes.
question for.
That is a good question. So, and then you also start using this like today. So for this, I can say that like for this framework, we already have all of these components in Orchestrator. We already defined some examples and show some demos of this AI analytical analysis tools, models. And we are working on this knowledge graph, how to connect knowledge graph to this openCHA. So this is, we are working on this. And for this health data, we already have like different examples connecting this health data. And like basically for this knowledge graph, we already connected this to like different guidelines and also to causal models that we already developed. And
one important thing that I want to highlight here is that our aim is to provide this open framework in a way that we can build a community around it, that people with different expertise from different perspectives can come over and help us implementing different aspects and challenges that exist here. It can be from different angles. One is that, for example, introducing new tasks like new AI models to detect to do other problems, or collecting data from different sources, or integrating knowledge and so on. So this is a thing that the part that is up there, the external source, is a thing that we hope we'll be able to create a community around, that different people with different expertise can come and contribute. Regarding the orchestrator itself, there are really interesting challenges there, that how this planner can be improved in a way that can decide in a better way, it can solve the problem in a more reliable way, we can provide the answers in a more trustworthy way, and so on. So there are lots of interesting open research problems there as well. Yeah, I just want to have
yeah, very good point. Thank you, Mahia. So, so the implementation of these external sources, so we need help from the community. Because, for example, we are not expert in knowledge graphs, or like, for example, in food knowledge graphs. And now we are collaborating with some like team to connect what they already have to such kind of framework.
Iman, there were questions from there.
Yes, we have other questions. So, is there a mechanism to use multiple sources to verify data in case where some data might not be up to date? So that's a very good question. And then we, in another track that Dr. Jain also mentioned about this evaluation metric. So we are working on this evaluation of these responses from different perspectives. And this up to date, this is like one of the metrics that we discussed in our paper. So, so these frameworks enable us to connect like these already sources that we have to these LLMs. But evaluation is not part of this. So this is like another track that could be beside this. So when you have like response, you need to evaluate it from different perspectives, including up-to-date.
Yeah, currently we are assuming that the sources that are connected have those properties like up-to-dateness, reliability, and trustworthiness. But for sure, later we can implement and develop some mechanisms inside the orchestrator, somehow to self-reflect or double-check those information with other sources, or we can connect it to different sources to decide which one is more reliable and so on. Apart from the evaluation part, that we will see this openCHA as a black box, and we want to see how performant the agent that we have made is working in that specific domain.
Thank you. One question.
When you use data to answer somebody's question, will you use particularly only the person, like the data specific to the person, or will you like look at other people's data and also use that in the decision-making process?
Yeah, but in our demos, we use like multiple data from multiple people. And then for the exercise today, we also give you the data of 5 people. But the question is like, for example, for patient 1 or for patient 3. So this part of like data data gathering or extracting data from the data set is the responsibility of this planning part. So we don't do it manually. We have 3 more questions, and I try to answer this quickly. How the planner LLM has been trained, how we can evaluate its performance as its performance score. Okay, so for the first part of your question, so we have not trained the LLM here.
Can you repeat the question?
The first question is that how the planner LLM has been trained. For our demos and for this example, we have not trained the LLM part. So we just use ChatGPT 3.5 turbo. But if you want to use it for a specific application, so as I mentioned, so you could also connect this, for example, to a knowledge graph, or you could fine-tune the model so the planning part could be improved. But this is kind of a generic framework. So yeah, so it could be
that maybe in the code part I will go into more detail in that, but for task planner, currently we are using the current reasoning techniques, prompt reasoning techniques that exist, like chain of thought, tree of thought, react, that exists right now, and they have shown that at least for this task that right now we are searching for, they are working well. And regarding the checking or evaluating their performance, currently the performance is that how well the correct tasks are selected and what is the rate of the correct task which is selected. And then we know that those tasks have a specific accuracies, like our AI model has 90% accuracy in defining the stress, or the other model have another accuracy, and so on. So there would be 2 different evaluation tasks. One is to check if the correct tasks are selected. The other is to know what are the accuracy or cumulative accuracy of each of those tasks. This is the current thing that's in the RAG models or any other evaluation techniques right now in LLM is undertaken, but we are moving forward to find better ways to measure the performance of this system.
Thank you. So this, I want to add to this, this evaluation is also, as I said, another track. So this is very important, and this should be done with the help of domain experts. For example, providing benchmark and to help to create this kind of evaluation metrics to evaluate these kind of chatbots. We have another question that what will change if we do not want to use OpenAI? So I believe we will go through this in the next session when we see the codes. But the short answer is that the framework is kind of modular, so you can easily change the LLM part to another LLM, for example, from OpenAI LLM to another one. And then we do not have this in our open source version, but we already tested with different LLMs.
As I mentioned, because we want to build the community, you are more than welcome to help us adding other LLMs inside the core to do the planning and these things. Currently, because OpenAI had better planning and reasoning capabilities, we decided to use it to show the whole thing is working and integrated. But as Iman mentioned, everything is modular, that I will show you in the code, that simply adding one new file that uses the other LLM can enable you to use another LLM instead of OpenAI.
And the last question is that what kind of personal health data from external sources may be transferred to LLM API during a conversation? So we had different demos for this personal health data. We tested with different smartwatch data, smart heart ring data, so data collected from smart devices. We also tested with logs of people, logs of person, on food log of the person. We also tested with this causal model, personal causal model that we created, but it could be any kind of data. But for the analysis part, we do not send it to LLM. So if it needs any kind of analysis, even some kind of statistical analysis, we try to connect. We do connect one component to do this analysis. So
your question is regarding concerning about sharing the data with these LLMs and so on. The thing is that we right now assume that the data is de-identified when we send it over to those OpenAI or other APIs. And also, there are different levels of privacy here. One is that we assume each of these external sources have their own privacy and security teams right now. That when we send the data over to them, they can handle it just or many other ways, and also they are HIPAA compliant or they are locally hosted, so the data is not leaked. And then the result of those analysis will be sent over to LLM in a de-identified way to make sure that no information, personal information is shared.